In this video, we're going to be solving a system of equations using a third method called elimination. So let's just recap. We have solved a system of equations using the graphing method, where we simply graph the two equations and look for the point of intersection. We have solved them using substitution. And substitution is best used when one of the equations has a variable with a coefficient of 1. Okay? And let's say we got something like this. Equals 1. Okay, we would solve this second equation for x and then substitute that into the first equation. And here now, we are looking at the elimination method. The elimination method, the goal is to get the same variable in both equations to have the same coefficient, but with opposite signs. And we're going to look at a nice, easy example to start with. So, notice that we have two equations, and right now they are aligned. The x variables are aligned, the y variables are aligned, the equals signs are aligned, the constants are aligned. That's very important to start the process of elimination. Now, a real question is, should I use substitution? Should I use elimination? Should I graph these? Well, notice that the y variables have the same coefficient but opposite signs. That is a dead giveaway that the easiest method for us to use in this case is going to be elimination. So to use elimination, we are going to add the two equations together. So we have 3x plus 5x is 8x, 2y minus 2y is 0y, and 4 plus 12 is 16. So notice that we have no y's left over. And we end up with one equation with one variable. That is very important. That is the goal. Because once you have one equation with one variable, it's very easy to solve that equation. Here we just have to divide both sides by 8 and boom. We know that x is equal to 2. Now in order to solve for y, what we can do is take that solution and substitute it back into one of the equations. And you get to choose which equation you want to use. Choose the one that results in the easiest math. So, looking at these coefficients, the first equation has smaller coefficients and all the coefficients in the first equation are positive, so I'm going to use the first equation. So I'm going to substitute 2 in for x, always doing so in parentheses. And let's see, we have 2y equals negative 2. So that means y is equal to negative 1. So that means our solution to the system of equations is 2, negative 1. That means 2, negative 1 is going to make both equations result in true statements. And you can see this when we go ahead and check our solutions here. So I need to check that point in both equations. So let me write both equations here. And then I'm going to substitute them in. Equals 4. Oops, I put my parentheses in the wrong place there. You're going to have to bear with me there. 6 plus negative 2 is equal to 4. Yes, that is true. And 10 plus 2 is 12. Yes, that is true. So both equations yield true statements. So this is our solution to this system of equations.